Hi, this is section 8.1, infinite sequences and summation notation. Okay, so this is what a sequence looks like. You have the first term, the second term, the third term, so on and so on. An infinite sequence is one that just continues to go on forever, indefinitely. Okay, so it says here, find the first four terms and the eighth term. So we got to find the first four, then the eighth term of the sequence. So to do that, you just substitute 1 for n, and you get 2 over 1 plus 2, which is thirds. Then you substitute 2 for n, you get 4 over 4 plus 2, that's 4/6. And then you keep going. The third, 2 to the third is 8 over 3 squared is 9 plus 2, that's 8 over 11. And then we'll do the fourth term. That's 2 to the fourth, which is 16, over 4 squared, which is 16, plus 2. All right, so that is 16 over 18. And finally, the eighth term, we plug in 8. So that's going to be 2 to the 8th, which is 256 over 8 squared, which is 64 plus 2. So that's 256 over 66. So if you write out the terms, you should get 2/3. 4/6 is 2/3 again. 8/11. 16 over 18, that would be 8 over 9. And let's see, 256. We can divide by 6, I believe. Nope, we can divide by 2, which is 128 over 33. All right, so that is your final answer. Okay, the next exercise, number 2, find the first 5 terms of the recursively defined infinite sequence. So this is a recursive sequence because it's defined in terms of the previous term. So the way they define it is you have to find the previous term. So that in those cases, they do have to give you the first term. So let's now find the second term, a sub 2. Well, if we're looking for a sub 2, that means k has to be 1. So k has to be 1. That means we have 1 plus 1, which is 2, equals 3 times a sub 1 minus 5. But with that a sub 1 is 2, it's given to us. And so now we get 1. All right, to find a sub 3, we're going to use the fact that k must be 2 now, because 2 plus 1 is 3. So k is 2. That means we're gonna say a sub 3 is equal to 3 a sub 2 minus 5. And we know what a sub 2 is. We just found out in the previous step. So now we have negative 2. And the pattern continues. Now we're going to say k is equal to 3. That's going to give us a sub 4 because 3 plus 1 is 4. So now we have 3a sub 3 minus 5, which is 3 times the previous answer, which is negative 2, minus 5 is equal to negative 11. So we do need to find one more. That would be a sub 5, 3a sub 4 minus 5, which is 3 times the previous answer, minus 5, which is going to be negative 36. Oh no, negative 38, I believe. That's negative 33. Take away 5 is negative 38. So the first 5 terms of the sequence would be 1, negative 2, negative 11, negative 38. And I forgot the first term is given to us. So it's first, second, third, fourth, fifth term. All right, the next one is similar in that it's defined by the previous 2 terms this time. So when it's defined in terms of the previous 2 terms, then that means they have to give you 2 terms to begin with. So we have the first, the second, so now we're looking for the third, which means that k must equal 2 because 2 plus 1 is 3. So k is 2. That means we want 3 times a sub 2 minus 2 times a sub 1. All right, we know what a sub 2 is. It is given to us. It's 1 minus 2 times a sub 1, which is also given to us, which is 3. So we get 3 minus 6, which is negative 3. And similarly to the one above, we're going to just increase k by 1. That's going to be 3 sub a sub 3 minus 2 sub 2 times a sub 2. It's always going to be the previous 2. So this is going to be 3 times a sub 3, which we know is negative 3. We just found out. Minus 2 times a sub 2, which is given to us as 1. So now we got negative 9 minus 2, which is negative 11. The next one, a sub 5, is going to be a sub 4 and a sub 3. And we know both of those. A sub 4 is negative 11, and a sub 3 is negative 3. So that's going to be negative 33 plus 6, which is going to be minus 27. All right. And now for the last sort. Actually, we're done. They only want they want the first 5 terms. So the first term is 3, the second term is 1, the third term is 3, the fourth term is negative, and the fifth term is negative 27. So 1, 2, 3, 4, 5. So this is what summation notation means. You got the capital sigma, and that's a Greek letter, and it tells you the term. It's in terms of k, so you start with the bottom number, which is 1, and then the sigma means you're adding, and then you just increase that by 1, you get 2, and then 3, so on and so on, until you get to the top number, which is where you stop. Okay, so there's a couple formulas. If you're just adding a constant and it's starting at 1, then the answer is just n times c. And similarly, if you're adding just a constant, but you're not starting at 1, you're starting at some number m, and you're ending at n, then the formula becomes n minus m plus 1 times a constant. So we'll do an example of those, both of those. So here, we start at 1, so you plug in 1, and you're going to get 1 squared minus 5. Then you plug in 2 squared minus 5. Then you plug in 3 squared minus 5. And finally, you plug in 4, and you get 4 squared minus 5, and that's where you stop. So if you work these out, you get, this will be negative 4 plus negative 1 plus 4 plus 11. And now you can just combine, you can just add these numbers up. So you should end up with 10 as your final answer. All right, same thing with this one. You start with 3 this time, and you end at 6. So if you start with 3, you're going to get 3 minus 5 over 3 minus 1, plus, then you go to 4 minus 5 over 4 minus 1. Then you go to 5. And finally, 6. All right, and if you simplify these, you should get negative 2 over 2 plus negative 1 over 3 plus 0 plus 1/5. All right, you will need a common denominator. Let's see. So, well, this is just negative 1 minus 1/3 plus 1/5. I'm going to call this 5 over 5. Or actually, 15 over 15. And then I'm going to multiply this one by 5 and this one by 3 to get an LCD of 15. So now I have negative 15 minus 5 is negative 20. Negative 20 plus 3 is negative 17. And that is our final answer. All right, so this is a constant, so we can apply, and we're starting at 1, so therefore we can apply this theorem, which says that the answer is just going to be n times c. So in this case, it's n times c. So it's going to be 5,000. All right, this one is it's a tricky question because you would think that you're going to plug in 1 into the k, but notice that this variable is not k, it's j. So you're supposed to treat the k as a constant because there is no variable. the variable is j and there's no j present. Therefore, this is treated as a constant. So because this is a constant and you're starting at 1, you're going to apply the same theorem that you did up here. So it's m times c, which is 7/2 k squared. That is our final answer. And that concludes this section.